All right, good afternoon. Approaching section 5.1. Let's see what we've got here. Now, this is basic properties and reducing to lowest terms. We don't know what we're reducing to lowest terms. Our objectives: reduce rational expressions to lowest terms. Okay, so what's a rational expression? And we're going to reduce those to lowest terms. All right, and then objective B is to find the function values for rational functions. Okay, that's using our notation, functional notation, so that should be fairly easy. And objective C, there is a C, but we're skipping that. All right, so we're going to focus here first on our objective A, reducing rational expressions. So what's a rational expression? Well, they're two polynomials, or not, they're a polynomial that are in fraction form. All right, so I could have something like 2x plus 4 over 3x plus 6, and that's an example of a rational function. Variables got to be in it, top or bottom. And that's what defines a rational function. All right, and it's as simple as that, really, for knowing what it is. All right, so we know about simplifying fractions itself. You know, I know I could have, if I use it in numerical form, I could say it's, say if I had 6 over 8. Well, what do we do when we simplify that? Well, I could say 6 is the same as 3 times 2, and that would be over 8, and 8 may be 4 times 2. Okay, and what happens now is I could write that as 3 times 2 this way, over 4 times 2, and then what do we see? When we're simplifying this, that the 2's cancel out. And I'm left with 3 over 4. And that's basically it for numbers. And we're going to do the same concept when we're doing rational functions. All right, so let me get my practice problem down here and see what we can do. All right, so here's our first example. And remember, all this is about is factoring. Everything we factor, and then we do our canceling, etc. But the main thing here in this section is that we want to know how to factor any and all these problems, if they're factorable. Now, looking at this problem here, if I could just go ahead and say, well, this is a difference of 2 squared, these two guys here and here. X squared is a square number, and so is 4. So then I know it's going to what? Going to come from x goes here and x goes here. I've got a minus and a plus sign. And then what's my number going to go here and here? That give me 4. And that would be a 2 here and a 2 here. All right, so that's factored. And then if I factor the bottom one, well, the lead coefficient is 1 now. So that tells me it's easy, and I'm going to set it up over here as part of my answer, because I know I'm going to arrive at my correct answer before simplifying, of course. So here I'm going to have an x here and an x here. What are my 2 signs going to be? Well, the first one's going to be negative, and the second one's going to be positive. Because a negative times a positive is a negative. All right, then I need a number for 8, I'll put it over here, that has a difference of, that will leave me with a difference of 2. And I believe I'm going to have 4 and 2. So 4 goes here, and 2 goes here. All right, that will give me my right. Negative 4 times 2 is negative 8. All right, so then when I come over here now, these are all lined up. I just got to do my canceling of like terms. So I'll have x plus 2 over x plus 2. They cancel. And what my answer is x minus 2 over the x minus 4. And then I'm done. All right, here is problem number 2. And think about what you know now while you're doing these. You know, the idea that, oh, the lead coefficient for the top function is 1. You know, you got 1x squared, so that's easy. So again, you can set up the parentheses ahead of time. Then I'm going to put it over the bottom. Well, that's a difference of 2 squares. Try to be cognizant of the difference of 2 squares. Those are probably the toughest ones when you think about it, right? So this is a difference of 2 squares, and you know, well, you can also say that the lead coefficient is 1, and that gives you another reason to set up your parentheses. All right, so as we do the top one then, let's do it. X and X. I got plus sign here. Remember, I'm just copying that first sign between the first and second term. Then I got to determine what sign is here. I don't recall having too many of these, but if this is negative here, that -8, that negative, what sign does this have to be for the answer to be negative? Meaning a positive times a what is a negative. And of course, that's negative. And then I got the same idea, same numbers. 8 is my number, and I've got, call it -8 if you want. Then I'm going to have a positive 2 in the middle. So that's 4 times 2. And what number is going to be negative? The 2 will be negative. So that'll go with the negative sign here, and the positive 4 goes here. So that works. The denominator have a difference of 2 squares. Well, that means it's x and x. When it's a difference of 2 squared, one sign is negative and one sign is positive automatically. And then I've got a 4 here, so that means I'm going to have 2 here and 2 here. And that's my factorization of that x squared minus 4. And remember how you check that. You multiply that together again. Okay, so what can I cancel here now are the x minus 2's. And I'm left with x plus 4 over x plus 2. Isn't that fun? I think it's a blast. Why not? Okay, on to number 3. All right, for number 3, we've got something different now. I've got a cube root problem. Is x to the third a cube number? Yes. Is 27 a cube number? Yes. So I can factor that, and that's going to look like what? Where does the sum and difference of 2 cubes come from? It comes from a binomial times a trinomial. Remember that? The bottom, can I factor this? Well, it looks like I can. I've got a 3 in front, but I want to check, can I factor that 3 out? And the answer to that is yes, because I got a 3 here, a 3 here, and a 36 here. So if I take out a 3, then what's left is the x squared plus x minus 12. All right, so I got a 3 along with this problem. I factored it out. Now I want to factor this trinomial here where the lead coefficient is now 1. Okay, great. Well, I can do that. I'm going to put my 3 here so I don't forget it. And then I'm going to have 2 binomials after I factor it. So what have I got? I've got an x here and x here. My signs are going to be plus and minus. And then I got a 12 here, 2 factors of 12 that have a difference of 1. Well, if I have a 12, then it's negative 12 too. So that means I'm going to have a 4 and a 3 because it has a difference of 1, that 1x in the middle. All right, now I have to determine which number goes with the negative sign. And it would be the 3 because 4 minus 3 is positive 1. So I'm going to put the 4 here and the 3 here. All right, so we got that little easier one out of the way, and now I'm going to factor this difference of 2 cubes. All right, and who remembers? We know it comes from a binomial times a trinomial. So let's put what? Let's set up our sign. I think that's easier. So the sign that goes here is negative because it comes from the problem. The sign in between the first and second term here is a plus, positive. And then this sign between the second and third is always positive. And that's our sign. Same, opposite, always positive for the slope. Okay, then I'm going to take the cube root of x to the third. That goes here, it's x. The cube root of 27 now is 3. And now I'm going to finish it. Once I get here to this binomial, once that's filled in, it's very easy to fill in the rest. The way I do it is I say, I'm going to take the first term here and square it. First goes with first. The second term is the 3. I'm going to square that. That's going to be 9. That's going to go at the end. And in the middle are these two terms here, 3 and x multiplied together. And that's 3x. Okay, everything's done. Now I got to do my canceling. And what am I going to cancel here? The x minus 3's look like they're going to be gone. And what's left over is x squared plus 3x plus 9, all divided by the 3 multiplier times x plus 4. You can try and factor this thing here, but it usually doesn't. So with that being said, that would be my final answer for practice problem 3. All right, so we did difference of squares. You can do sum of squares, but you can do difference of cubes and sums of cubes when you factor. And watch out for those. A lot of watching out we're doing here. But it gets a little more complicated as you're learning this. You know, you're getting up to intermediate algebra here, so that's nothing to thumb your nose at. And a lot to learn, a lot to remember as you're doing different problems. All right, now on to number 4. All right, here's number 4. They're getting bigger, but that's okay. I'm going to do my work down below here because I may have to. So let's see, I've got xa plus 3x minus 4a, that's an a, minus 12. Let's do the top first, okay? So what do I know? I got a 4-term polynomial here. Whenever I have a 4-term polynomial, I'm going to group it. I'll use some brackets now. No reason. The left side here, what can I take out? I can take out an x here. If I take out an x, I'm left with xa divided by x is a, plus 3x divided by x is 3. And then minus sign, that's going to come down. I'm just copying it and factor the right side here. It's 4a minus 12. I can take out a 4. And what's left over is a plus 3. Negative 12 divided by negative 4, positive 3. All right, now I'm going to take out the common binomial factor of a plus 3. If I took it out, then I'm just going to say to myself, what's left over? X minus the 4. So that there is my numerator. So I'll bring it over here. Equals a plus 3 times x minus 4. I'm going to do the same thing over here to this denominator. I'll do my workspace over here. I try to minimize my writing, and you want to as well, whenever you can, without it detracting from what you're trying to accomplish. Okay, so I've got it recopied here, and again, 4-term polynomial, we group them and factor the two binomials. So here I'm going to have an a out, and then what's left is x minus 2. I'm going to bring down the plus sign, and then 3x minus 6, I'm going to take out the 3. And when I divide that back, I'm going to have x minus 2. All right, and I'll say I'll take out the common binomial factor of x minus 2. I could write it up there now at this point, but I don't want to throw you off. So if I took out the x minus 2, then what's left is a plus 3. Okay, so that'll go over here, x minus 2, and a plus 3. There. And now we're at the point we can do our canceling of like terms. So the a plus 3's go. They cancel each other out, and I'm left with the answer. I'll put it in red. X minus 4 over x minus 2. And that would be my final answer. All right, that wasn't too bad. I mean, it's a lot. It takes a little bit more time to go from beginning to end on a lot of these problems. That's what a lot of people got to get to understand and accept. We're done with the easy answers like 4 times 8, you know, and you just write, you see the problem, you write down an answer. Now we got to work these a little bit more and get into it. I think it's kind of neat. It detracts from your personal problems when you do math. I swear, it works. All right, how about number 5? Let's go. All right. Here is, it's going to be easy. After I explain this to you and how we arrive at our answer, whenever you see opposites like we have over each other, you're going to know why the answer ends up being -1. And that's what it is. So 3 minus a over a minus 3 will always equal -1. They're opposite of each other. Here I have a 3, a positive 3, on the bottom it's minus 3. The top is minus a and the bottom is positive a, and the like. But how is that? Why is that? Well, I could look at this and I could say, well, if I factor out a negative, let's say I pick on the top one. All right, and what I'd really like to do is match that, so they're both a minus 3. All right, but let's say I have a 3 minus a here. If I have 3 minus a, and if I decide I want to factor out a negative, I'll say I'm going to factor out a -1. And when I do that, I'm going to now put back what's left over. So I'm going to say 3 divided by -1 is -3. And negative a divided by -1 is positive a. So now I could take these two numbers inside the parentheses and flip them around using the rule of the property of the commutative function, if I'm saying that right. All right, so this is the same as a minus 3. So if I rewrite this to be -1 times a minus 3 and now put that over the denominator, which is already just a minus 3, then what happens? Sure, the a minus 3's cancel, and you're left with negative 1. So that's the arithmetic behind this equaling negative 1. You'll see it and you'll say, oh, that's negative 1. That's all. And if you have to explain it to somebody, then that's the explanation. Okay? All right. I may ask you that on a test too. So, beware. You've been warned. All right, so that's number 5. As simple as that. And you'll encounter this in problems. The opposites. Okay, next. All right, here's our next problem. 2x squared minus 8. Well, I'll do a little work down here. 2x squared minus 8. And I'm going to take out a 2 here. And what's left? X squared minus, because I got negative 8 divided by 2 is negative 4. Oh! And then what do we got left in the parentheses? Anybody notice it? Yeah, it's the difference of 2 squares, that same x squared minus 4 we had earlier. So that tells me that complete factorization of the numerator is going to be 2 on the outside, and then I can set up my parentheses for the difference of 2 squares, the factorization of the difference of 2 squares. So what, 1 x and x, that's always minus, so it's minus and plus. And my numbers that I'm going to use are 2 and 2. A lot of 2's here. All right, so my numerator is factored. Oh, and look what it's over. 2 minus x. Okay. So here's a little important test for you. Which one does this cancel with? Which one would be the opposite? Would it be x minus 2 or x plus 2? Well, they got to be opposite, right? So if I picked x plus 2, well, this is a positive 2 here, and so is this. They're not opposite. It's going to be the x minus 2 with the 2 minus x. So if I cancel these two out, that part equals negative 1. And I could put the negative 1 anywhere in the front. I could just make that 2 a negative. That would be okay as well. Or you could put it out front. But that means negative 1 times that 2, which is negative 2. All right. That being said, I'm looking at what's left over, and it's negative 2 times the x plus 2. You would not multiply them together, by the way. And this is your answer. Okay. Remember that. Just take the negative and put it out in front. If you did not have that 2 there, let's say you had a couple parentheses like x plus 4 and x plus 5 for whatever reason, then that if I said it's negative, put a negative right there, and that would be the solution. You could put negative 1, but you don't have to. All right, now we're moving on to our second objective about rational functions. So we're going from rational expressions to rational functions, and the difference is this here equal sign. So now we say f of x equals x plus 5 over x minus 3. All right, that's all we're doing, and it really doesn't change much. All right, so now they want us to use functional notation to solve this. So if f of x equals x plus 5 over x minus 3, well, f of 5 is going to equal, I'll do it here, f of 5, oh, sorry about that, f of 5, what do I do with that? What does that mean to do? I'm going to plug in 5 for the x in the function. So that would be 5 plus 5 over 5 minus 3. And I'm going to get 10 over 5 minus 3 is 2. 10 divided by 2 is 5. And that's all you have to do for that. You're just plugging it in and plug and play, as I always say. Okay, so I'll do something real quick here to change that. It's not in our lesson to do, but I just want to harp on it a little bit more. And that would be if this were f of 0. If that were f of 0, then what would I do? F of 0. I would take the 0 and plug it in for the x's then. Okay, and I could squeeze in my answer here. My answer would be 5 over negative 3. Okay, that's all. That's all I wanted to say. Okay, I'm going to have to talk a little bit about this because here we're talking about the domain again. Way back in chapter 2, we talked about the domain. And the domain are all the x values that take on values that are along the x-axis, okay, of a particular function. So we did some earlier, but let's revisit that a little bit more. So if I have a function, and let's just call it, let's start with something easy. How about x plus 1? All right, and if I said, what is the domain of the rational function x plus 1? Well, we could say that x can be any number whatsoever. Any kind of number, any real number it could be. And I'm going to get a result. So if I said x was 2, then 2 plus 1 is 3, so 3 is on the number line. If I said x was a half, then a half plus 1 is 1.5. And that number is on the number line. The only time you have to understand when the domain has a break in it or it's not there, number is not there, is because it only happens when you have a denominator. All right, so if I just have a standard problem here, it's really over 1, so it's just the numerator. But if I put something like, how about x over x minus 1? Okay, if I did that, then what is the domain? Do I have is the domain in all along the x-axis, or is there going to be a break there because it doesn't exist there? All right, so let's try something here. Here's a number line, or the x-axis, if you will. And if I said that x is 2, if this is 2, if x is 2, what would y be? So let me kind of cheat up here a little bit. I'll make that darker. This is the y-axis, just for explaining this. All right, if x equaled 2, then what would f of x be? Well, I'd replace 2 for the x here, and I'd have 2 over 2 minus 1 is 1. So 2 over 1 is 2. So when x is 2, y would be 2. And that would be a plotted point there. Okay? But now, let's say if I said x were 1. If x is 1, then the top would be, I'll write over here. This top over here would be, x would be 1. And then on the bottom, it would be 1 minus 1, which is 0. Oh, and here's the problem that we're having. I've got 0 in the denominator. Okay, so that can't exist. So when x is 1, this is undefined. And therefore, I'm going to have a break there. I can't put a point anywhere on that line of x equals 1. Because it doesn't exist. All right, and that's what I'm talking about. What do you notice? My function here has a denominator along with a variable. So if I have a variable, there's a number that could make that equal to 0. Make what equal to 0? The denominator equal to 0. Okay, and that's what is not allowed. So my answer would be x such that x does not equal 1. That would be your domain. And then on the line here, I'm just showing you briefly, this is a break here that doesn't exist. If you plug it into your, I wish I could show you my calculator screen. I'm going to try that one time. If you plug that into your graphing calculator, you'll see that the line doesn't exist. There's a break there. Okay, let's try that. I hope you're understanding what I'm saying, but maybe after the examples here, we can, you'll get a better understanding of it. Okay, hold on. All right, here's practice problem 8, and then I may do the example 8 as well. Let's try this. All right, I have to find the domain of this function. And really, I've got to write this up as, maybe it has on the example q of x. Q is just the name of the function with my equal sign. That makes it a function now. All right, so I've got this, and well, if I'm finding the domain, that means, and I have a denominator. So I have a denominator with a variable in it, so I want to get this denominator equal to 0 and solve for x. Or I could just factor it too. Let's try and factor that. Okay, so let's see. I could say, let's see, equals 0. Get it equal to 0. That's better. All right, so then for here, I could factor out the 2. And then what's left is x squared minus 4. Oh, that again. Okay, now we can look and see if this is equal to 0. I can continue to factor that. That's a difference of 2 squares. So I could say it's going to be 2, and then I'll set up my parentheses with x minus 2 and x plus 2. And I'm just doing this. We've had this 3 times at x squared minus 4. Okay, this is all in the denominator. And there's an x on top. So this is x over 2 times x minus 2 times x plus 2. Okay, everything's factored. Now what will make this equal to 0? What would make that equal 0 in the denominator when x is what? Well, it looks like when x is 2, then 2 minus 2 is 0, and 0 times anything is 0. So that's a number that's not in the domain. All right, so x equals 2, and for this parentheses here, let me highlight that a little bit anyway, this parentheses, x would have to equal negative 2. And that makes this denominator equal to 0 when those two numbers are, when it's 2 or negative 2. So my domain then is going to be x such that x does not equal 2 or negative 2. And that would be the domain. That's how you state it. You don't list all the numbers that are in the domain. You'll be here forever, right? Because it goes to infinity. So you write your answer as the numbers that make it 0 in the denominator. And make sure you write your not equal. It cannot be equal to those numbers that make it 0 in the denominator. Let's do a couple other quick ones, all right? And then you'll get the hang of it. So example 8, I don't even need that, I can make it up. X minus 4 over x minus 2. What's the domain? The domain are all real numbers x such that x is not equal to what number? x is not equal to 2. Because 2, if I have 2 for x, 2 minus 2 is 0. You can't have 0 in the denominator. It's illegal. How about x cubed minus, I'm deviating a little bit from the example in the problem, from the example in the book. And then here I've got x plus 1. All right, and again, I'm like, what is the domain? The domain is any number x such that x cannot equal, what number would make it 0 in the denominator? It would be -1, because -1 plus 1 equals 0, and you can't have 0 in the denominator. So you're writing the numbers that are making the denominator 0 and still saying that's the domain. All the other numbers are in. I could put 2 if I want. I could put 3, 4, 5. I put any number, 100, 1,000,000, but I can't put -1 because of that rule of it being making that 0 in the denominator. Okay, that's it for today. That was section 5.1, and very nice. If you have any questions, you can send me a email or a text or however you want to communicate. Okay? All right. Have a good day, rest of the day, and take care.